In the last video, we introduced the Nash bargaining solution. In this video, I'm going to introduce another very important solution concept in cooperative game, which is the Shapley value. That is based on each player's marginal contribution. And Shapley is another very important contributor to the game theory. Both John Nash and Louis Shapley were mathematicians, and Nash won the Nobel Prize in 1994, while Shapley won the Nobel Prize in 2012. So this is the quiz from the previous video. If you haven't done this, then please try to answer those questions by yourself. So this is what we did last video, and we defined core and Nash solution is the most egalitarian point within this core. So that's the closest point from the equal allocation of a non-separable value. So this is the Nash solution. But what I asked in the quiz is the situation with the value of A and C is 65, not 10. So when this was 10, then these are core. But now A and C jointly require 65 or more. So there is no core. There is no area that satisfies all the restrictions. So in this game, core is empty. If the core is empty, then we cannot define Nash solution. So that's the problem. So in many situations, core can be empty because the ground coalition generates not enough surplus. So now we are going to introduce another very important solution concept, which is Shapley value. The Shapley value is the average of each player's marginal contribution. The marginal contribution is, so for instance, player I's marginal contribution to any coalition S that doesn't include S is the difference between the value of S union I and just the value of the S without I. So that is the difference is the player I's marginal contribution. And we are going to get average of each player's marginal contribution. This is just the combinatorics number of such cases. So I'm going to explain how to compute Shapley value. As I mentioned, we are going to consider each player's marginal contribution, and we have to consider all the possible coalition formation order. So for 3 players, there are 6 coalition formation order: ABC and ACB, BAC, BCA, CAB, CBA. So those are all possible order. And for any particular order, for instance, ABC, A form a coalition first, A form a coalition first, then A takes her own marginal contribution. So without her, the value was 0, so she takes 10 from 0. So we can say the empty set, the value of empty set is 0, so the difference between the V of A and the V of empty set is 10. And after which, Bob joins. So now we have to consider the difference between value of AB and the value of A. the difference is now 50 minus 10, which is 40. So 40 should go to Bob. And after that, after A and B, now C coming to the coalition. So they generate 90, and the marginal contribution, the difference between 90 and 50, which is 40, goes to the player, the last player, car. Okay, so for this particular order, they split the surplus 90 in this way, 10, 40, and 40. Now we consider another possible coalition formation order, A, C, B. So A comes first, again A generates 10. Now C comes later. So what we have to consider is AC, but at this point, the marginal contribution of C is 0 because without C, A still can generate 10. So here, C's marginal contribution is 0. And after that, B is joining to the coalition, and B takes the marginal contribution, the difference between 90 and 10, 80 go to the Bob. Okay, so things are the same. So let me do another round here. B, A, C. So B comes first, B takes 20, after which A joins, and then they form a coalition A and B. So the difference is now 30. So A takes 30, after which C joins, and the difference between 90 and 50 is 40. So 40 goes to the car. Right? So we do this exercise for the other coalition formation order, and then take an average for each player. So it's just a routine, so we can find the Shapley value to this game is this vector. So 16 and 2/3 to A, and 51 2/3 goes to Bob, and 21 and 2/3 goes to the third player. So of course we can point that allocation in this chart, in this diagram. So Shapley value places here. It's a little bit different between the Nash solution and the Shapley value. But important thing is, even the core is empty, still we can define Shapley value. So in the previous quiz, we considered the value of AC was 65, and let's do the same exercise. So previously, VAC was 10. Now A and C generate more by 55. Right? So everything the same. So A, B, C, they form a coalition A, B, C. Then A takes 10, and Bob takes the difference 40, and Carl takes the difference 40 in the order of A, B, C. This order doesn't change their allocation of the surplus. Now let's think about another order, A, C, B. So now A takes 10, and now C joins. Right? Previously, value of AC was 10, so marginal contribution of C was 0, but now marginal contribution of C is now 55. So after N, Carl added the marginal contribution by 55, the difference between 65 and 10. And Bob, who joined the last order, is going to take 25, the difference between 90 and 65, right? So that's the 25. Actually, this marginal contribution now transferred to car. Everything's the same, and there is another order that influence to the allocation, which is the CAB. C comes first, takes 0, and then A can enjoy this bigger marginal contribution. So N's marginal contribution is 65 from 0, and then Bob joins player B. The difference between 90 and 65 is just 25. So again, this contribution, marginal contribution that were assigned to Bob is now assigned to N. So anyway, so we can find the Shapley value even in this game with empty core. So the Shapley value is here. So this is the quiz. So please find the Shapley value of this correlation game and think about slightly different situation if A contributes more by the same amount to the correlation includes A. So by comparing two situations, you can see another good property of the Shapley value.